So great. So now that we have the interface here, which will give a minimalistic ABI for us to interact with the contract, how do we actually get the pricing information? Well, again, if we go back to the docs, we can see right here, it gives us an example of the code we can use to get the latest price. But let's write it ourselves just so that we know what's going on. We'll say aggregator v3 interface, and we'll actually create a new variable called price feed equals aggregator v3 interface contract at this address, which again only works for Sepolia. Now we can call this latest round data function on the price feed. So we'll say price feed dot late round data. And if we look at the interface on GitHub, we can actually see latest round data doesn't just return one variable, it returns a whole bunch of different types of variables. And to return multiple types, we do some syntax that looks like this. And we'll say uint 80 round ID. And you can even flip back and forth between the documentation, make sure you have it right. Int price, which again, we know an int defaults to an int 256. Uint 256 started at, uint 256 timestamp, and then uint 80 answered in round. Oh, there's a lot of code in here. Since this function returns so many variables, we have to set something up to capture them. But we don't care about any of this other stuff. We just care about price. So what we can do is actually just remove them and leave the commas in there. So we're going to remove started at, remove timestamp, remove answered in round, and I hit Command S to compile. We're going to get these yellow squiggly lines, which are warnings, but we're going to fix them in a minute. Now we have int price equals price feed dot latest round data because we only care about getting the price from the return. The reason price is an int 256 is because some price feeds could be negative. Now that we have the price, this price variable is going to be representing the price of ETH in terms of USD. And it's going to return a number that looks like this because again, Solidity doesn't work with decimals. So we know that this price feed has 8 decimals, but it'll get a return like this. Boom, like this. It'll return a value that looks like this. If we want to double check how many decimals there are in a price feed, it actually has a decimals function, which allows you to check that as well. Now, as we know, message.value is going to have 18 decimal places. How do we know that? Well, because we know that 1 ether is equal to this many Wei, and this many Wei has 18 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. So this massive number is equal to 1 Ethereum, right? 1.12345678910 1 2 3 4 5 6 7 8. So right now message.value and price actually have different decimal places. Price has 8, message.value is going to have 18. So to get them to match up, we have to do return price times 1e10, or to add those additional 10 decimal places. And yes, I know we have a red line. I'll fix this in a minute. Price, as we know, is a int 256. And message.value is going to be a uint 256. So the types are actually different. So we want to get the price in terms of uint 256 instead of int 256. To convert them, we can again do a thing called typecasting. There are a lot of different types that can be easily converted between each other. Not all types can be typecasted, but an int and a uint 256 can be. So to make our price a uint 256, we would just do uint 256 and wrap price like this. Or we could just wrap both of them like this. Now, of course, since we're not modifying any state, but we are reading storage, we can make this a view function, and then we'll say it returns a uint 256, like so. And now if we compile, we get rid of all those errors and warnings. Now, math can be a little bit tricky in Solidity, but the more you do it, the better you'll get. And the reason math can be tricky is because there aren't any decimal places, so you need to only work with whole numbers. The more you work with it, the better you'll get though.